Hi there, and welcome to Lesson 77C, Real World Problems. Our goal today is to be able to write an exponential growth or a decay function in order to solve a real world problem. Remember that this is the exponential function. A represents the starting amount, which is the y-intercept or when x is 0 at time of 0. And when you're dealing with a real life problem, that is your starting amount. Then the B, that's our growth or decay factor. It's what we're multiplying by. It could be a number that's bigger than 1, and that's growth. If it's a number smaller than 1, it's decay. And remember, if it's exactly 1, it's neither. The X then, of course, is still our time periods. Okay, let's start with example number 1. An isotope of barium has a half-life of 13 days. If 100 grams of barium disintegrates over a period of 52 days, how much would be left? Okay, let's break this down. What is our starting amount? Our starting amount here is 100 grams. So I've got 100 grams of barium. Now, what's happening to the barium? It's disintegrating, right? And it's disintegrating by half-lives. Now, what is its half-life? Says its half-life here is 13 days. So every 13 days, it disintegrates in half. Well, we're wondering how much is left after a time period of 52 days. Well, how many half-lives is barium going to have in 52 days? So what I'm asking is, how many 13-day periods are there in 52 days? Well, that's just a simple division. If you take 52 divided by 13, it's 4. So this is 4 half-lives, 4 periods of 13 days in that 52 days. Now that we understand the situation, let's see if we can write an exponential function to represent what's going on. Here's my exponential function, and I'm going to fill in what I know. So I know the starting amount, and that is 100 grams of barium. That's going to go here. Now my multiplier right here, this is my factor of change, that is half-life. I want to cut this in half. So what do I multiply by to cut something in half or divide it by 2? Well, you'd have to multiply by the fraction 1/2. Multiplying something by half will cut it in half. It will take half of it. Okay, so half-life, I'm just going to plug in 1/2 right in here for my B value, my multiplier. And now my time periods, that's how many half-lives. How many times do I want to take this 100 grams of barium and disintegrate it in half? Well, I want to do that 4 times because every 13 days it's going to disintegrate in half, and after 52 days, there's 4 half-lives. So 4 is going to be my exponent. I want to take 100 grams of barium and I want to cut it in half 4 times. Now, in your calculator, this is what you're going to type in, or use order of operations if your calculator doesn't have the parentheses and everything. Let's see what's left. My calculator says 6.25. We're asked how much would be left. This is in grams. So I would say 6.25 grams. That's what would be left of the barium. Now I want to model really quickly how this is actually working. So I'm going to get rid of some of this stuff here so I have a little bit of space. Okay, so I want you to go back up to this picture. Right at the start, we have 100 grams of barium. You see, it's all blue. After 1 half-life, which is a period of 13 days, it gets disintegrated in half. So I would have only 50 grams of barium. Another period of 13 days goes by, and now I only have 25 grams of barium. It gets cut in half again. Another period of 13 days, another half-life, I would be at 12.5 grams of barium. And then another half-life, one more half-life getting me to 52 days, will be 6.25. So I'm literally taking that 100 grams of barium, I'm dividing it by 2 or taking it in half 1, 2, 3, 4 times. Okay? And the exponential function does that work for us. All right, let's try another one. Here we have a radioactive kind of iodine. It says how much of a radioactive kind of iodine will be left after 120 days if you start with 720 grams and the half-life is 15 days. Okay, let's figure out what we've got going on here. We're starting with 720 grams of this iodine. Now it's disintegrating, right? Because it tells us it's got a half-life. So it disintegrates in half every 15 days. We want to know how much is going to be left after 120 days. Well, how many half-lives, how many 15-day half-lives are there in 120 days? That's a division problem. Let's take 120 days. We're going to divide it by 15-day half-lives. And when I do that in my calculator, I get 8. So we have 8 half-lives. 8 15-day periods in that 120 days. Now I think we're ready for our function. Okay, our A value is our starting amount. Remember, we're starting with 720 grams. So 720 goes here. Now our B value is what we're multiplying by. This is half-life. So I want to multiply by half, which you know that's going to take it in half of. And then our X up here, this is our time periods. How many half-lives are we going to have? Well, we figured that out to be 8 half-lives. There's 8 15-day periods in the 120 days. So we want to cut this in half 8 times. Now, with our calculator, let it do the work. Go ahead and type it in. We started with 120 grams. How much will be left after 8 half-lives? You should get approximately, well, calculator says probably like 2.8125. So if I went out to like the 10th place, 2.8, that would probably be close enough. 2.8, and then it says how much would be left, so there'd be 2.8 grams. Not a whole lot. All right, hopefully we're getting the hang of this. On number 3, a lab technician is culturing a bacteria sample. The current population is 2,000 bacteria, and it is tripling in size every 4 hours. How many bacteria will there be in one day? Okay, so from this information, I can tell that the starting amount is 2,000. What's the factor of change? What's happening to the bacteria? They're tripling. Let's circle the word tripling. They're tripling. So this is growth. And they're tripling every 4 hours. We want to know how many bacteria will there be in a day. Well, if it's tripling every 4 hours, let's change this day into hours. So let's say 24 hours. That way our time periods, our labels will be the same. Okay, so it triples in size every 4 hours. How many bacteria will there be in 24 hours? Well, how many 4-hour periods are there in 24 hours? How many times do we want this to triple? If it triples every 4 hours, there are 6 4-hour periods in 24 hours. So I want this to triple 6 times. Okay, I think we're ready for our function rule. Okay, first box, that's our beginning value, 2,000. Oh, gotta get the marker. Okay, now what are we doing? What are we multiplying by? What's this right here, this number, this factor of change? Remember, it says tripling. So we want to triple it. We want to multiply it by 3. Okay, here we got multiply. We're multiplying by 3. Now the X is our time periods. How many times do we want to triple this? Remember, we said we're going to triple it 6 times because it triples in size every 4 hours, and there's 6 4-hour time periods within 24 hours. So we want to triple it 6 times. So now again, you just type that into your calculator. Let's take the 2,000 bacteria. We're going to triple them 6 times. It's going to kind of be like a lot. So calculator is going to say 1,458,000. Bacteria grows really, really, really fast. So that does make sense that that would happen. Cool. Number 4, back to termites again. Things that double and triple and quadruple, right? A population of 150 termites is doubling. Ooh, I'm going to circle that doubling. That's my factor of change. It's doubling every 45 minutes. How many termites will there be after 540 minutes? Well, how many times are we doubling this? It doubles every 45 minutes. So how many 45-minute time periods are there in 540 minutes? Division problem again. Let's take 540 minutes, divide it by 45-minute time periods, and when you do that, you're going to get 12. So if these termites double every 45 minutes, there's 12 45-minute time periods in that 540 minutes. We need to double this 12 times. Okay, I think we're ready to write our function rule. A is the start, and that's 150. What are we multiplying by? What's our factor of change? Right here, you guys, double. We're doubling it. And then how many times do we want to double this? We want to double it. It doubles every 45 minutes. So remember, there were 12 45-minute time periods in that total 540 minutes. We want to double it 12 times. Imagine 150 termites getting doubled 12 times. That's huge exponential growth. And the calculator should say 614,400 termites. Wow. You got a problem. Termite problem. All right, number 5. Barium 122. The 122 just is part of the name. Barium 122 has a half-life. Ooh, right here. I'm going to circle that keyword right here, half-life. There's my factor of change. It has a half-life. It's disintegrating in half. It's got a half-life of 2 minutes. Every 2 minutes, it cuts in half. A fresh sample weighing 80 grams. There's our starting. We have an 80-gram sample of barium. If it takes 10 minutes to set up an experiment using this barium, how much will be left when the experiment begins? So as soon as you take it out of its package, every 2 minutes it's disintegrating, half of what it was before. So if you got this 80-gram sample and it takes you 10 minutes to set up your experiment, what are you going to have left when it begins? Okay, now that we have an idea what we're being asked, let's go ahead and set up an equation. So we know we're starting out with an 80-gram sample. 80 is our starting amount. What's happening? What are we multiplying by? What's our factor of change right here? Half-life. We want to cut it in half, so we're going to multiply by half. Okay, how many times do we want to do that? How many times are we going to cut it in half? So how many half-lives are we going to have? If the half-life is 2 minutes and 10 minutes passes us by, how many 2-minute periods are there in that 10 minutes? Yeah, 5. So we're going to cut this in half 5 times. Use your calculator. And you should get 2.5 grams. So you only have 2.5 grams of barium when your experiment starts. That's all you've got because it disintegrates so quickly. Wow, crazy. On number 6, here we've got uranium. So there's just a little picture there of what uranium looks like. The half-life of uranium-232, remember that's part of the name, uranium-232, is 70 years. So what do we know here? We got half-life, right? It's going to disintegrate in half. It says it's 70 years old. How many half-lives will it take for 10 grams of it to be reduced down to 1.25 grams? Ooh, we're being asked now for the time periods. Little different. It tells us we have 10 grams. So this is our starting amount. It's got half-lives, and we're wondering how long it's going to take to be reduced down to this much left. All right, let's organize this in an exponential function. Okay, our starting amount right here, 10 grams. It's a half-life, so we know what goes in here, half. We're multiplying by half, but what we don't know is the time periods, right? So that's what we're trying to figure out. Like this is our x right here, and we're not quite sure what the time periods are, but we do know that we're wondering how many time periods it's going to take to reduce it down to 1.25. So we want what's left to be 1.25. What would the time period be for that to happen? How many half-lives? So you got some choices here, 1, 2, 3, or 4. So go ahead and put those into your equation in place of the x and see which one is going to take that barium down to 1.25 grams. Did you figure it out? Yeah, it's actually 3, isn't it? So if you were to type in 3 as the exponent into this function, it's going to take it down to 1.25. So 3 half-lives. So think if the half-life is 70 years and you have 3 half-lives, that would be 210 years it would take for this uranium to go from 10 grams all the way down to 1.25. All right. Number 7. We're going to see how this relates to money here in number 7 and 8. Mrs. Nader deposited $560 into an account that earns 15% interest annually. Compounded annually means every year she's going to get 15% interest. To the nearest cent, how much money will she have in 3 years if she keeps this in her account, doesn't touch it? Okay, so we start with, or Mrs. Nader starts with $560, and it's going to earn, that money is going to earn some interest. 15% interest is being earned, so it's going to increase, and we're wondering what she's going to have left after 3 years. So I think we got enough information here for us to write down an exponential function. Now, do you see how I have a big space in my parentheses here? You'll see why. So what's the beginning amount? 560. Let's put that in the first box. Okay. Now we are growing by a percent. So do you remember what we need to put here in our B value if we're growing by a percent? 1 plus. And then I'm going to take that percent, decimal, back it up, take off the percent, and that's 0.15. And then the time period would be 3 years. Okay, so go ahead and type in your calculator if you want to change this to 1.15 to make it easier, because you know that would be 1 plus 1.15. You could do that. Let's see what your calculator says. What is Mrs. Nader going to have in her account after 3 years? To the nearest cent. Looks like we're going to get $851.69. There we go. That's what she's going to have. Now, do you see how she started out with 560 and then she ends up with $851? This function rule added the interest that she earned right on and it gives you the entire total after 3 years. That's because we use the 1 in here, the 100%. This function took 100% of the money she started with and added on the interest for you. And $851.69 is what she's got. All right, let's see how this next one is different. This one's about me. All right, Mrs. Johnson deposited $300 into an account that earns 5% interest compounded annually. To the nearest cent, how much interest will she earn in 2 years? Now, notice what's different about this one. It's asking how much interest I'm going to earn. That makes this a little bit different than the last one. And I want to know how much I'm going to earn in 2 years. Okay, I think we're ready to set up our equation. Because it's a percent, I'm going to have a pretty big, pretty big parentheses here. I got a lot to put in there. Okay, we're starting with what, $300? Okay, and because I'm making interest, my money's going to grow. So this is 1 plus. And then go over to the 5%. Remember decimals here, back it up, take off the percent, 0.05. And then I want to know what I'm going to have here after 2 years. So 2 is my exponent. And then right here, this is 1.05 if you add it together. So you could just use that to type in your calculator. Okay, let's see what the calculator is going to say here. Now, the calculator is going to give you the amount of money that I'm going to have in my account after 2 years of earning that interest. So do you see how after you type it in, your calculator tells you that this is how much money you'll have? Okay, so it makes sense. I started with $300 and now I have $330.75. But I'm not done yet because that's not the question it was asking. It was asking how much interest did I earn by leaving my money in the account. So if I started with $300 and now I have $330.75, by leaving this money in my bank account for 2 years, I made some interest. How much interest? Well, you just have to subtract the two to figure that out. And you could do this in your head. $330.75 minus 300 is an interest amount of $30.75. That is the amount of interest that I earned after leaving my money in the account for 2 years. So careful when you're doing your practice today. Some of the questions will ask you how much total money, like in the example with Mrs. Nader, and some are going to ask you how much interest, like in the example with me, where you're going to have to subtract at the end. So just be careful that you're kind of watching for the directions there. Okay, let's review. We're going to have pull it all together here. I'm going to be giving you some situations, and you're going to tell me what is the constant factor of change for each situation. So if you are asked to double something, what would be your factor of change right here? What would be your B value if you're asked to double? Great. If you said 2, you are right. So if I'm doubling something, I want to put a 2 right here in this spot. All right, let's try another one. What if you're asked to triple something? Something's happening and we want to triple it. What is your factor of change that you're going to put right here? Oh, if you said 3, you are right. Perfect. Be sure you're filling these in your notes. Now, what if I had a situation where it was a half-life? What would the B value, what would the factor of change be right here? Oh, if you said 1/2, you are right. You're multiplying by half, which is going to cut it in half or take half of it. How about if it was a percent increase? We were growing in percentage. What would happen right in here for your B value? If you said 1 plus the percent, you are right. And then if we had a percent decrease or a percent decay, what would be your B value right here? If you said 1 minus the percent, you are right. So these are all the different scenarios that we've seen and that you probably will see, the double, triple, half-life, percent increase and percent decrease. You are ready for anything. So in summary, here was our exponential function. Those were all the parts to it. And we were able to solve real-life problems. Thank you for joining me today. I hope you have a great one.